Dear colleagues, I would like to present a report reducing the risk of power equipment failure when using information from information measurement system of vibration diagnostic rotation units or auxiliary engine of power plant. The power station are in critical infrastructure, so reliability and resilience of its operation is an important component of state security. The reliability of the power equipment is closely related to the effective monitoring and diagnostic systems they are equipped with. The construction of such systems takes place in several stages: the elaboration of mathematical models of information signals of such systems, the selection of the most informative diagnostic features based on the analysis of such models, the construction of training sets and decision rules. When solving such a problem, the theory of probability, the theory of random plots, the theory of risk, machine learning theory of statistical hypotheses, the theory of pattern recognition are applied. Any complex technical facilities can always be viewed as a hierarchical structure. Thermal power plants contain a large number of units, mechanisms, machines, and structural elements. The individual units and components of thermal power plant collectively constitute certain functional blocks, the reliability of which to a certain extent depends on the reliability of the equipment included in the each blocks. Science defects in the component part are actually defects in the facility as a whole. The auxiliary equipment of power plant includes mechanism for servicing of automation, the operation of the main units and auxiliary devices of the plant, intra-station power grid and switchgear, as well as heating, lighting, and so on. Prototype of a wireless diagnostic system was developed in the Institute of Electrodynamics, Ukrainian National Academy of Science. The analog signal measured at the units of the electrical machines under diagnosis at the output of the sensor is duty cycle modulated signals. The ADXL202 accelerometer manufactured by Analog Devices was used as primary sensor. The sensor unit used in the developed prototype of the vibration diagnostic system consists of the following basic elements: two ADX accelerometers, microcontroller manufactured by Microchip Technology, Bluetooth module manufactured by Toyota, related elements, and ensure the full functioning of the unit. Using the creation prototype of the information system, research of the vibration characteristic of auxiliary engine of Darnitskaya head of power plant was carried out. The developed vibration model of the prototype of diagnostic system was used to measure and analysis of vibration information signals recorded on the bearing unit of rotation shaft of the DICA RIE 4519 4V electromotor. The development of diagnostic systems that cover all possible elements of power plants is too complex a technical problem. Therefore, when a diagnostic system is developed, it's necessary to determine which elements of the object to be diagnosed are critical for its proper functioning and which are less critical. It is advisable to divide all possible defects in a given object to be diagnosed into three classes: catastrophic defects, non-catastrophic defects, and partial defects from the point of optimization, the complexity of the diagnostic system. Method of resilience estimation of actual electric drivers of power plant was applied. We used the methodology proposed into the access the impact of auxiliary motors of the power plant's resilience. According to the definition of the United States National Academy of Sciences, the structure Structure as a model of the object of study is modeled as a graph G of NL, when N is the number of nodes connected by links L. The specification N and L includes characteristics related to the resilience, such as capacity, location, and the impact of each node, and connection lines of the functioning of the object research. We try to develop the schematic diagram of the main auxiliary motors involved in the operation of power units at the blocks of Tripolian thermal power plant. A critical functionality by which resilience is estimated with following equation, where NL is the set of the all needs and links of the graph, where sub E of Ts is a measure of the relative importance of node or link I at the given time t. P sub E of Ts is the degree of which the node is still active in the presence of all attack. E is a class of reversible events or potential attacks on target nodes. Resilience. Resilience is a complex function of the topological property of the network and zero-time evolution parameters defined for a certain critical functionality and class of adverse events E. The definition of resilience are shown at the slide 11. The paradigm of risk analysis in the energy sector is certainly related to the risk paradigm that exists in the development of cybersecurity systems. According to this paradigm, risk information security includes three main dimensions: confidentiality, availability, and integrity. The additive risk model information security can be presented as follows, where R sub C, P sub C confidential risk, R sub E, P sub E integrity risk, and this one availability risk. Risk identification. The following paradigms are possible to access the risk of power unit failure. R sub P, P sub R sub C, P sub C is a confidentiality risk. This corresponds to the risk of unauthorized access to the wireless receiver and the technical condition of such receiver. R sub C, P sub C integrity. It is estimates service life and probability of failure of a power equipment. R sub E, P sub E is availability risk. It is the actual service life and probability of failure of a power plant, which depends on the operation mode and technical indicator. For example, for vibration, it's according to the following international standards could be applied for estimation of this operation modes and temperature indicator. Load characteristic could be estimated with application of the international standard. Conclusion. The relevance of the result obtained is due to the fact that in the post-war period, one of the main problems of the country's reconstruction should be the restoration of its united energy system, including generation equipment. It's necessary to restore generation at a fundamentally new level with the use of advanced achievements of the world and domestic electrical engineering. Such restoration involves restoration not only the main generation equipment, but also auxiliary equipment, which may not be severely damaged during enemy attack. But it's necessary to assess the risk of its failure and impact of the functionality of all part equipment. This assessment can be made using the concept of resilience. Thank you very much. for your attention.